Hello guys, and welcome in this new quick recording. This is going to be very short tutorial actually, I hope so at least, on how you can use timestamps query in WebGPU, and more specifically we're going to be focusing on native WebGPU using the down library as usual. So let's get straight into it. First, I just want to mention the wiki article. So it's this one that I have written when I was working on that. So it's going to provide you some additional details and additional code snippet if you want to get more well, inspiration on this topic, I guess. We're going to get back to some of those code section, so let's just not focus too much on that. So just wanted to mention this article anyway. And next, also what I need to mention is this one, the Omar Shiata. This is a reference article which I was using myself when I was trying to implement that, except that in this case the implementation is done with the regular WebGPU. So this is for your browser implementation then, but basically it's the same thing if you want to use that in a native WebGPU. So yeah, that's what I use as a starting point, and I basically try to follow what was explained here. But at the same time, if you I just mentioned that if you just have a look at your WebGPU CPP header file, you're probably going to figure out directly what you need to do to deal with those timestamps, because if you search for timestamps, you're going to find a few references like this one. So you see that in your command encoder you can write a timestamp, but you need a query set for that, and you can also resolve some query set apparently in a command encoder, and there's not that many references for the query set. So if you just keep searching for query set after that, you will find how to create a query set. You will find the base class itself. You will find this structure, for instance, a compute path timestamp, right? And apart from that, it's pretty easy to figure out what you need to do in the end when you have those structures. So what is the next thing I wanted to mention? Yes, in the WebGPU specification also you can have some additional info concerning the timestamps query. An important piece of information that you need to keep in mind then, I guess, is you can make some queries to get timestamps, but you have this timing limitation here. Apparently it's dangerous to have precise timings on the web. So there is a mechanism in place to reduce the precision of the time value that you're going to retrieve in your timestamps, which is a bit of a pain because the results that you get in the end are not very precise. But yeah, I guess it's better than nothing. The thing is, what you also need to keep in mind is that timestamps query are currently considered an unsafe feature, so they are in fact disable by default, and if you want to enable them in your engine, in your native WebGPU engine, you also have to activate a specific toggle, an additional layer of security. So there's the feature itself and the toggle on top of it. If you do not activate the toggle and just request the activation of the feature itself, the device creation is going to fail because you're going to get a validation error. So in this case, you need to activate this allow unsafe APIs toggle. So let's just have a look, in fact, on this point number 4, on what you should do exactly to create your device in this case. So for my part here, I'm going to make a request for a few different features. Those 2 features here, you don't need anything to activate them. So I'm trying to activate them all the time. But then when it comes to the timestamp support here, I have a specific preprocessor value which is going to deactivate that if I want to build the release version of the engine, but otherwise when I'm building the debug version I'm going to try to activate that. So you make the request for the feature here, then you prepare your device descriptor, and this is the part which is new on my side here. You also need to prepare a structure with the toggles here and specify that you want to enable this allow unsafe APIs toggle. So you can have a look at this page in fact to get some reference on why we're doing it this way. One additional thing I could mention here is that this has changed a lot lately, because initially it was something like disable unsafe API, so it was enabled by default or something like that, don't remember. And now it's this syntax. Okay, once you have this toggle specified, activating those features should work just fine, and then when you create your device you're not going to get an error, so that's great. Okay, so that's concerning this point. What else? I also wanted to mention that you basically have two mechanisms then to make your timestamps query, because you can either make the query directly on the command encoder. So we've seen that in fact in the WebGPU API here. If you look for write timestamp, that's yeah, you have that in the command encoder, so you can just request a timestamp while you're preparing your command buffer. And the second way to do it is actually to specify that you want to get timestamps directly on the compute path or a render path. That's where you're going to use those timestamps write structure that we mentioned just before. We've seen that in the CPP header file. I'm not absolutely sure myself what's the real difference between the two. I would assume that if you make the request here on the compute path, it's going to be a little bit more precise than if you try to write the timestamps and execute your compute path and then write another timestamp in the command buffer. But I'm not sure about that, so don't trust me, don't just believe what I'm saying. And okay, so what I should mention finally is that for my part I decided to encapsulate a bit the ending for all those timestamps and how you're going to deal with them when you're debugging your application. So for that, let's just have a look again at the article. So the first version, so that's an example of the first usage case that I had for timestamps. I'm trying to write some reduction compute shaders, so that's why it's pretty handy to be able to start monitoring the performances and figure out how long it's taking to execute the shader. So what we're doing here is concerning timestamp retrieval, you have to create the query set. So you have a query set here. You also have to create a corresponding buffer, but then when you're going to write the data in your buffer, this will be on the GPU, and if you want to get that on the CPU side, you will have to download the data, so you need the staging buffer. So that's another buffer that is related to the first one. Then I was writing those timestamps initially, providing the query set and specifying that I want to write in the timestamp slot 0 here, then executing a compute path and writing another one in the slot 1. This was a third one in fact, not very relevant. And when you're done, you have to resolve your query set. That's where you're going to specify that you will get the data from the query set and write that into the buffer. And after that again, you have to copy the content of this buffer, which must be on the GPU and not mappable. So you have to copy that into your staging buffer. And only after that you can, yes, at this point you can retrieve the data that you have in the staging buffer, and this would be the nanoseconds value of the timestamps that you have written initially here. So this was working fine, but that's too much work every time you want to retrieve some of those timestamps. So basically what I did was to encapsulate everything concerning the creation of the query set and the buffers, and just simplifying the interface. So what I have currently is something which is rather like that. So you can still make a query for a timestamp directly in your command buffer, or you can also, when you're building a compute path, it's a bit hidden here, but I'm going to support providing indices where I want to provide timestamps. So for the start and end of this compute path, for instance, and here you don't need to specify the query set or the buffer. What I'm doing myself is I'm going to create a query set for the timestamps and a corresponding buffer directly in the engine here, and I'm using that whenever I'm calling the corresponding write timestamp function on the command builder. So yeah, I don't think it's really necessary to go into the details, but that's at least simplifying the interface that I'm going to use then in all the unit tests where I want to measure the execution time. That's definitely a good step, I think. And yes, I guess this is it. Then I'm going to retrieve timestamps differences here, because this is what I'm doing most of the time. So instead of retrieving one by one, I'm computing differences directly this way. And from there, yeah, nothing much more to add. Then I can maybe just show you what's going to happen if you run this. It's going to report the total execution time, which is the value which is here, and that's the accumulation of the time taken by each compute pass here, and I'm executing a few of them in a row. That's actually a mechanism that I'm using myself, trying to improve the significance of the timestamps by augmenting the number of data that I'm collecting. So statistically, I guess at the end it could maybe converge to an approximately correct value for the duration of the compute path, but not so sure about that either. So that's the best I can do, and yeah, so far for me it's working pretty good, so I'm keeping it this way. Okay, so this is it, guys. So as usual, if you have any question, just let me know in the comments, and otherwise I'll see you another time for another small tutorial like this one. Bye bye.